Now that you know what reciprocal functions are, let's look at some more formulas that you'll need to know now in Pure 3. And there is a bunch of new formulas that you need to know. This is the bad news. I'm going to give you the good news in a bit. So you need to know 3 different classes of formulas: the compound-angle formulae, the double-angle formula, and the forms r cosine of theta plus or minus alpha and r sine of theta plus or minus alpha. What is this? This basically is a formula that allows you to determine the value of the sine, cosine, or tan of the sum or difference of 2 angles, here represented by theta and phi. Okay? So if you have the sum or the sine of the sum of 2 angles, this is what you'll do to figure out the value of that sine. This is for the difference. For the sum, now for the cosine, the sum and the difference. Now for the tangent, the sum and the difference. Do you have to memorize these? No, because you have MF19 and you have them over here. This is going to be, as you know, with you during the paper. And by the way, I hope that you already have a printed and annotated MF19 with you as you solve exercises, and here you have them. Okay, so you have here the sum and the difference. And how do you read this? I want you to pay attention to a detail. Here you have the sum, so now here you have a plus, here you have a plus. Here you have a minus, here you have a minus. But look here, for the sum of 2 angles, now you have the difference of this product. Okay, how is this shown on the MF19? Whoops. Can you see here? Here you have the sine of A plus and minus B, and here you have the expression plus and minus. But for the cosine, you have the other way around over there. The plus now turns into a minus, and the minus now turns into a plus. Did you see this detail? This is very important for you to be able to read what the formula says. So for example, cosine of A plus B equals cosine of A, cosine of B minus sine of A, sine of B. Same thing over here on the tangent. If you have the tangent of the sum of 2 angles, the top of this fraction is going to keep the sign that you have over here, but the denominator is going to be the other way around. If you have the sum, this is going to be 1 minus tan of A, tan of B. If you have the difference, this is going to be 1 plus tan of A, tan of B. Okay? Again, how do you work with these? Pretty much the same way as you did last year when you were doing identities. You have to be able to look at the expression and identify, always with this in front of you, what is going on until you reach the desired goal. Another class of formula that you need to know is this, the double angle formula. And what does this do? This divides an angle in 2 parts. So if you have the sine of a certain angle, let's say 60 degrees, sine of 60 equals 2 times sine of 30 cosine of 30, right? You can always divide the sine, the cosine of or the tangent of an angle into its half by applying this formula. Again, you have them in the MF19. Here they are, for the sine, for the cosine, and for the tan. You may think that for the cosine you have more than you should, but no, if you look close enough, you see that this is a combination of this formula with the one that you learned last year. Where is it? This one over here. For example, if you substitute here the cosine square of A by 1 minus sine square of A, this is what you'll get. This is what you'll get. You'll get 1 minus 2 sine square of A, right? So these 2 are the combination of this with that one. Okay? All right. The one that requires some more explanation is the last class. It's this. The forms r cosine of theta plus or minus alpha and r sine of theta plus or minus alpha. Let's start with this bit over here. If you have a coefficient times the cosine of a sum or the difference of two angles, and same thing goes for the sine, you can use the expression that you've learned before, that is over here, these over here, all of these, and just multiply all these terms by this coefficient r. That's what I did over here. Okay? Here you have the r. But the point of this is, as I'm going to explain, let's focus on this particular angle theta over here. If we focus on this theta, everything else is just going to be a coefficient. So r cosine of alpha is going to be a coefficient, and r sine of alpha is also going to be a coefficient. And same thing goes for all the other three. I'm focusing on this one, but what I'm saying is valid for any other that you have over here, all the other three. Okay? So if I just call this A, and if I just call this B, then this is what I'm going to have. R cosine of alpha plus theta plus alpha is going to be A cosine of theta minus B sine of theta, right? And sometimes you will see trigonometric expressions expressed like this. And the idea is that you are going to be able to use the coefficients A and B to figure out what R is, for example, and what the angle alpha is as well. How do you do this? Again, A is R cosine of alpha, and B is R sine of alpha. Let's square them. So R squared cosine square of alpha plus R squared sine square of alpha is going to be equal to A square plus B square, right? I can just factorize the R squared, right? So I have that A squared plus B squared equals R squared, open brackets, cosine square of alpha plus sine square of alpha. But this is 1, right? So you can just have that R square of alpha equals A squared plus B squared. Okay? If I want to put this just as terms in terms of R, so R is going to be the square root of A squared plus B squared. What does this mean? It means that if you have an expression represented like this, in which you have two numbers over here, let's say 2 cosine of theta minus 3 sine of theta, you can express this as this, and you already know how to calculate this value r. This value r is just going to be the square root of 2 squared plus minus 3 squared, and you get the value r. What about the value of alpha? Well, look over here. A is r cosine of theta, right? B is r sine of theta. R is the square root of that. Already have done that. But if you divide this by that, B by A, the coefficient of this one by the coefficient of that one, the r's are going to cut out, and you just have B over A. And you'll have also the sine over the cosine, which is what? Is a tangent. So the tangent of that value, of that angle alpha, is going to be B over A, which means that the angle alpha itself is going to be tan negative 1 of B over A. So here you have two expressions that will allow you to represent anything like this into something like this. See? Again, how'd you get R? Is the square root of A squared plus B squared. Okay? How'd you get the value alpha? Is tan negative 1 of B over A. As simple as that. Now, with all of these, you are going to be able to solve a new range of questions, and that's the purpose of our next videos.